Okay, good morning to everyone. This is Dr. Sailaja, working as Associate Professor of Mathematics, MLR Institute of Technology, Hyderabad. In this class, we are going to study about rank of a matrix, elementary transformations and matrix, and finding rank of matrix by using echelon form. So, first we see the definition of rank of a matrix. Let us take a square matrix capital A equal to Aij of order n by n. Rank of the matrix is less than or equal to n. That is, maximum the rank of the matrix A is n, and it is less than n also, and it is denoted by R of A or rho of A. Suppose A is a square matrix of order m by n, then rank of A is defined as minimum of m comma n, and it must be less than or equal to minimum of m comma n. That means, suppose A equal to the matrix Aij of order 3 by 4, then rank of A must be less than or equal to minimum of 3 comma 4. Minimum of 3 comma 4 is 3. So, rank of A is less than or equal to 3. Simply, we can define the rank of the matrix is number of non-zero rows in a matrix, and the properties of the rank of the matrix is unique, and if the matrix is a null matrix, then the rank is 0, and always the rank of non-zero matrix is greater than or equal to 1 if it is non-zero matrix. If the matrix A is of order m by n, then rank of A is less than or equal to minimum of m comma n. So, this is the example of that square rectangular matrix of order 3 comma 4. Next, elementary transformations and matrix. To find the rank of the matrix, we apply elementary transformations and matrix. So, here elementary transformations, we take the matrix A equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Suppose this is the order of the matrix 3. To find the rank of this matrix, we apply elementary transformations on this matrix. So, what type of transformations we can apply to find the rank of the matrix? Row transformations and column transformations. So, we can interchange rows and columns. We can interchange rows and columns. That means, for example, we take two rows R1 and R2. We are interchanging two rows R1 and R2 means this is the notation of interchanging two rows. That means we place first row in the second and we place second row in the first. That means we are interchanging first row and second rows. So, R1 and R2. Or we can interchange the columns also C1, C2. Interchanging, this is first column and the second column. We place a second column in first column and we place C1 in C2. This is the first type of transformation, and the second type is multiplying ith row or column by a scalar k. Suppose we take any row Ri. I want to multiply this ith row by some scalar or constant. Then this Ri becomes take any scalar k Ri, where k is any scalar, k belongs to R. For example, if we take a third row, I am transforming third row by multiplying this third row by a constant 3. So 3R3. Then this third row becomes, R3 becomes, the elements are 3A31, 3A32, 3A33. That means multiply all the elements of third row with the constant 3 or scalar 3. So this is second type of transformation. Similarly, column also. We can multiply any column. Cj is transformed to kc3, where k is kcj, where k is any constant. Next type of transformation is multiplying all the elements of jth row or column by constant k and adding to corresponding elements of ith row or column. That means, suppose I want to transform the first row as R1 plus 2R2. That means now the first row elements are transformed by taking the transformation as R1 plus 2R2. R1 is A11, A12, A13, and 2R2 is multiply the second row elements with 2, then the elements becomes 2A21, 2A22, 2A23. Now add these two rows, that is A11 plus 2A11, A12 plus 2A22, A13 plus 2A23. Now my first row elements are this. First row is transformed to these elements. Now the new matrix is A11 plus A21, 2A21, A12 plus 2A22, A13 plus 2A23, and the next remaining rows are same, that is no change in the remaining rows, A21, A22, A23, A31, A32, A33. So these are different types of transformations we can apply on a square matrix or rectangular matrix to find the rank of the matrix. Now we take an important method to find the rank of the matrix, that is echelon form. So echelon form means reduce the matrix, given matrix, reduce the given matrix A to upper diagonal matrix, upper triangular matrix, upper triangular matrix. That is A equal to, in the form of A11, A12, A13, 0, A22, A23, 0, 0, A33. So here A11, A22, A33, these are the principal diagonal elements, and below the elements of these principal diagonal elements are zeros. So this type of matrix is called a upper triangular matrix. That means we reduce the given matrix A to this upper triangular matrix. This matrix form is called echelon form. So to reduce into upper triangular matrix, strictly we apply row transformations only. In echelon form, we apply only row transformations. And always we place 0 rows in the last row of the matrix. Now take one example. Find the rank of the matrix 3, 4, 5, 2, minus 1, 2, 0, minus 3, 1, minus 1, 1, 4. The order of this matrix is 3 rows, 4 columns. So, the rank of the matrix must be less than or equal to minimum of 3, 4. Since this is rectangular matrix. So, if it is a rectangular matrix, the rank of the matrix is less than or equal to minimum of 3, 4. So, in this 3, 4, the minimum value is 3. So, therefore, rank of the matrix must be less than or equal to 3. So, either 1 or 2 or 3. Now, what is the rank of the matrix? We will do now by using echelon form. Now, this is the given matrix. So, to reduce this matrix A to echelon form, strictly we apply row transformations. So, always reduce the matrix into upper triangular matrix. That means here the diagonal element is, first diagonal element is 3. So, below these diagonal elements, the elements must be 0. So, this element and this element we have to make them as 0. So, before making these elements as 0, so take the first diagonal element as 1. So, for that I am applying that row transformation R1 interchanging to R3. That means interchanging R1, this is R1 first row and this is R3 third row. In the third row, the first element is 1. So, that's why I am placing third row in first and first row in third. So, this is interchanging R1 and R3. Then the matrix become, so third row elements are 1, minus 1, 1, 4, 1, minus 1, 1, 4 and second row is same, no change in the second row, minus 1, 2, 0, minus 3 and first row is becomes the third row, that is 3, 4, 5, 2. Now the first row becomes the third row 3, 4, 5, 2. So this is interchanging rows, first row and third row. Now the first diagonal element is 1. Now below these diagonal elements, the elements are minus 1 and 3. So how to make minus 1 as 0? So take this minus 1 is in the second row and 3 is in the third row. Now, we apply the row transformations on second row and third row to make these elements as 0. So, these elements are under the first diagonal element 1. So, take the row transformations on second row and third row. So, second row as, how to make this minus 1 as 0 means, add second row and first row, minus 1 and plus 1. Then this element becomes 0. So, that's why I am taking the transformation as R2 plus R1. So, here R2 is minus 1. R2 elements are minus 1, 2, 0, minus 3 and R1 elements are 1, minus 1, 1, 4. Now add these two rows 0, 1, 1, 1. So these are the second row elements. Now the second row becomes 0, 1, 1, 1. So this is the second row in new matrix. Similarly, third row is transformed by taking the transformation R3 minus 3R1. Why we are taking this transformation? So to make this element 3 also 0, that's why we are taking R3 minus 3R1. That means we are multiplying the first row with the scalar 3. That is scalar multiplication. Now R3 elements are 3, 4, 5, 2 and 3R1. 3R1 means we are multiplying all the elements of first row with the constant 3. That is 3 minus 3, 3, 3 into 4, 12. So here to make this element as 0, we have to subtract these two rows. That is R1 and R3. Now 3 minus 3, 0, 4 plus 3, 7, 5 minus 3, 2, 2 minus 12, minus 10. So we are doing subtraction. Now this is the third row elements in the new matrix. Third row elements are 0, 7, 2, minus 10. So 0, 7, 2, minus 10. The first row is same elements, no change in the first row. That is 1, minus 1, 1, 4. Now the new matrix is first row, second row, third row. That means the first step is make the principal diagonal elements as 0, minus 1 and 3. The next diagonal element is 1. So below this diagonal element also we make it a 0. So here 7 is there. In the second row 1 is there. Now take the transformation on R3. To make this element 0, multiply the second row with 7 and subtract these two rows, then this element becomes 0. Now the transformation is R3 minus 7R2. Now the elements of R3 are 0, 7, 2, minus 10 and second row elements are 0, 1, 1, 1 and multiply with the constant 7. Then this becomes 0, 7, 7, 7. Subtraction. 0, 7 minus 7, 0, 2 minus 7, minus 5 and minus 10, minus 7, minus 17. So this is third row elements in the new matrix. Now place these elements in the third row and remaining two rows are same, that is R1 and R2 are same and the third row elements are 0, 0, minus 5, minus 17. So now observe this new matrix. All the elements below the principal diagonal elements are zeros. Now this is upper triangular matrix. So this form is called echelon form. Now the matrix A is reduced to echelon form. Now in this matrix, number of non-zero rows. Here non-zero rows means all the elements in the rows are non-zero. That is here non-zero row, first row is non-zero, second row non-zero and third row also non-zero. That means at least one element of the row is non-zero, that is called non-zero row. So here 3 non-zero rows are there, that's why the rank of the given matrix is 3. Number of non-zero rows in echelon form is 3. That's why the rank of the matrix R of A equal to 3. So that's why if it is a rectangular matrix, the rank of the matrix must be less than or equal to minimum of 3, 4. Now we got the rank of the matrix is exactly 3. Now take the second example. Find the rank of the matrix 2 minus 4, 3 minus 1, 0, 1 minus 2 minus 1 minus 4, 2, 0, 1 minus 1, 3, 1, 4 minus 7, 4 minus 4, 5 by reducing to echelon form. So here the order of the matrix is 4 rows and 5 columns. So the rank of the matrix is less than or equal to minimum of 4, 5. So in this minimum value is 4. Therefore, rank of A must be less than or equal to 4. That is either 1, 2 or 3 or 4. Now, we reduce this matrix into echelon form by applying row transformations. So again, echelon form means upper triangular matrix. See, the first diagonal element is 2, but in the second row it is 1. Now, interchange first row and second rows. Then, the new matrix is, here the second row becomes the first row, that is 1 minus 2 minus 1 minus 4 2, and the first row becomes a second, that is 2 minus 4 3 minus 1 0. Remaining 2 rows are same, that is 0 1 minus 1 third and fourth rows are same. Now the first diagonal element is 1. Now make the below these diagonal elements must be 0. Now in the third row, this element it is already 0, so no change in this element. In second row and in fourth row, make these elements as 0. So in the second row, 2 is there, in the first row 1. Now take the transformation on R2 to make this element as 0, R2 minus 2R1. Then only this element becomes 0. So R2 elements are 2 minus 4, 3 minus 1, 0, and R1 elements are 1 minus 2 minus 1 minus 4, 2. But to make this element 0, here the element should be 2. So multiply the first row with the constant 2. Then this first row becomes 2 minus 4 minus 2 minus 8, 4. Now subtract these two. Then you will get 0, 0, 3 plus 2, 5, minus 1 plus 8, 7, 0 minus 4. Now this is the second row elements. 0, 0, 5, 7 minus 4. Now make the fourth row element 4 also 0. So that's why take the transformation on fourth row by multiplying the first row with 4. Then fourth row is 4 minus 7, 4 minus 4, 5, and the first row multiply with 4 is 4 minus 8 minus 4 minus 16, 8. To make this element 0, subtract 4 minus 4, 0, minus 7 plus 8, 4 plus 4, minus 4 plus 16, 5 minus 8. Now this is fourth row element. So in the new matrix, the fourth row elements are 0, 1, 8, 12, minus 3. Now this is the new matrix by taking the transformation on a second row and a fourth row. Observe here, below the first diagonal elements, all the elements becomes 0. But here, in the second row, the second diagonal element is 0. Remember, always the diagonal elements must be non-zero. So that's why interchange the rows here. In the third row, the element is 1 here. Now interchange second row and fourth row. In fourth row also we have the element is 1. Interchange second row and fourth row elements. Then the matrix becomes like this. Now observe, the second diagonal element is 1. Below this diagonal element, 1 is there, that is in the third row. Make this element also 0. For that, take the transformation on R3. If we subtract second and third rows, then this element becomes 0. So that's why R3 minus R2. So this is third row and this is second row, 0 minus 0, 1 minus 1, 0, minus 1, minus 8, minus 9, 3, minus 12, minus 9, 1 plus 3, 4. So here below the second diagonal elements also 0. Now the third diagonal element is minus 9. So below this element is 5. So make this element also 0. For that, take the transformation on fourth row, R4 minus 5 R3. That means multiply with 5, then this element also becomes 0. So here now finally we got the matrix is in echelon form. First row, second row, third row. This is upper triangular matrix. The matrix is reduced in upper triangular matrix and this is in echelon form. And the number of non-zero rows are 1, 2, 3, 4. So number of non-zero rows are 4. So that's why the rank of the matrix is 4. Therefore, R of A equal to 4. So this form is called echelon form and or upper triangular matrix. So to reduce in echelon form, strictly we apply row transformations. So this is easy method to find the rank of any given matrix, either it is a square matrix or rectangular matrix. So today we discussed a very important method to find the rank of the matrix by using echelon form. In the next class, we are going to discuss about to find the rank of the matrix by using normal form. Thank you.